to the 20s, you will need your unit pack cover. It's blue. And we're going to be using some rules that are at the very bottom of that unit pack cover. So here are the rules. These rules I'll be addressing as we're going through the problems rather than reading them all to you. And then here's even some more rules. So again, I'll be addressing those rules as we go through the sheet. All right, so the first thing that we need to do is we need to assign oxidation numbers. As we do this, please feel free to pause the video at any point in time so you can work ahead and then be checking your answers. So the oxidation number here, I gotta get a pen. The oxidation number here is at 3 positive, and here's at 3 positive. And oxygen in a compound is 2 negative, and hydrogen in a compound is 1 positive. And then oxygen is a 2 negative, but there's 7 of them, so that's 14 negative. The whole thing's got to add up to 2 negative because of this charge right here. So what plus 14 negative equals 2 negative? That's 12 positive. And there's 2 chromium, so each one is a 6 positive. If you're not doing this work above it, it might explain why you're going to be getting some problems wrong. I don't need any of this information now, so I'm going to erase it so it doesn't confuse us with anything else that we are doing. This is a 2 positive, and this is a 1 positive. If you're not quite sure about how I did the oxidation numbers, you should really go back and do the 5s and the 10s where we taught you how to do oxidation numbers. So going right off the cover, we're skipping right on down the cover. The first step was to assign oxidation numbers. The next one is to do the brackets that we've already learned how to do on the 5s and the 10s and even the 15s. So we're going to circle oxidation numbers that change. So they change for iron. So I'm circling those. And they change for the chromium. So I'm circling those. The next step is I'm going to identify the oxidation number that decreases for an element. So the iron goes from a 3 positive to a 2 positive. That is a reduction in oxidation number. I write RED for reduction. RIG. Reduction is the gain of electrons. So gain, how many electrons did it have to gain to go from a 3 positive to a 2 positive? It gained 1 electron. Next, I look at the chromium. I go from a 3 positive to a 6 positive. Oil oxidation is the loss of electrons. Both of those are on the back of your periodic table, upper right-hand corner. It goes over oil rig. Also, the 5s and the 10s did that as well. So, oxidation is the loss of electrons. This 3 positive lost 3 electrons to go to a 6 positive. Lost, lose, what have you, 3 electrons. The next step is to fill in these 4 boxes right here. So if you did a good job with your brackets, this should be fairly easy. So what's oxidized? Well, the Cr3 positive was oxidized because I have my bracket going to that element. What was reduced? Well, I have my bracket going to the Fe3 positive. Now comes the slightly hard part, is figuring out the oxidizing agent and the reducing agent. First of all, I want to tell you, everything comes from the reactant side. None of these 4 boxes comes from the product side. Everything comes from the reactant side or the left side of the arrow. So here we go. Listen carefully. Pause the video if you need to. Replay the video if you need to. The oxidizing agent. What causes this chromium right here, these chromium-3 ions, to become oxidized? What causes these chromium-3 ions to lose electrons? It is these iron ions that need to gain electrons that force the chromium-3 ions to lose electrons. So the Fe3 positive is the oxidizing agent. The Fe3 positive forced the chromium 3 positive to lose electrons. The Fe3 positive is the oxidizing agent. The reducing agent. So, what caused this Fe3 positive to gain electrons? It was the Cr3 positive needing to lose electrons that caused that. So the Cr3 positive will be the reducing agent. Everything comes from the reactant side. The next step going down on your cover, and I sure hope you are going down the directions on your cover and following along, is to write out the half reactions. So oxidation. So I write Cr3 positive from my bracket, arrow going to the other end of the bracket, Cr2O7, 2 minus. A lot of students forget the 2 minus and the 3 positive. The next step says balance everything besides hydrogens and oxygens. So to do that, I put a 2 here. Now my chromiums are balanced. The next step says balance the oxygens by adding water to the side that needs more O's. So I add 7 H2Os to this side to balance out the O's on each side. And again, please feel comfortable with pausing the video, reading the instruction, trying to justify what's going on. The next thing I need to balance is the hydrogens. So here I have 14 H's. On this side, I don't have any H's. So I'm going to add 14 hydrogen ions to this side to balance out all the H's. Now I have all of the elements balanced, but I do not have the charges balanced. I have a 3 positive right here, and I have 2 of those 3 positives. So I have a 6 positive on this side. On this side, I have a 2 negative, and I have 14 of these 1 positives. So on this side, I have a 12 positive. I add electrons to the side that's more positive to get both sides to the same overall charge. So again, 6 positive here, 12 positive here, so I add 6 electrons to that side. In an oxidation half reaction, that's what we're doing, oxidation half reaction. Electrons are always lost and are always found on the product side. Now I have to do the other half reaction. Fe3 positive to the other end of the bracket, Fe2 positive. Balance everything besides hydrogen and oxygen. The Fe's are balanced. Balance the oxygens. There is no oxygen, so we don't have to do that. Balance the hydrogens. Don't have to do that. Balance the charges. This is a 3 positive, this is a 2 positive, so I add 1 electron to this side, and now the charges are, in fact, balanced. I'm going to change pen color real quick. All right, the next step as you're going down the cover is these electrons over here that are lost need to equal these electrons over here, which are gained. So what I have to do is multiply one or both half reactions by a number to get those electrons to equal out. The top one's a 6, so I'm going to multiply the bottom one by a 6. So this turns into 6 electrons, 6 Fe's, and another 6 Fe's. Change pen color again. Now it says in the instructions, things that are on opposite sides of the arrow cancel each other out, and things on the same side of the arrow are added together. So I have 6 electrons here, and I have 6 electrons here, and they cancel out. So there's no overall electrons written into our balanced equation down here, so that makes sense. I go right down the line. How many Fe3 positives do I have? I have 6 of them. How many Cr3 positives do I have? I have 2 of them. How many H2Os do I have? I have 7 of them. How many Cr2O7s do I have? I have 1 of those. How many Fe2 positives do I have? I have 6 of those. And how many hydrogen ions do I have? I have 14 of those. And that's how you do the problem. I'm going to do one more teacher-led problem, but I would love it if you would do The second one, see how far you can get before you get stuck. Please pause the video as you need to, rather than just copying down what I'm doing. Here's a prettier version of everything that I just did. All right, so I'm going to go through this problem. You can pause the video. Please try this problem and see if you do, in fact, get stuck. So here, each one of these is a 1 positive. So this is a 2 positive overall. So this has to be a 2 negative. This is a 1 positive. This is a 2 negative, but there's 3 of them. So that's a 6 negative and a 1 positive. So that's a 5 negative overall. So this must have to be a 5 positive. This is a 2 negative, but there's 4 of them, so that's an 8 negative. The whole thing's got to add up to 0. Hydrogen's a 1 positive. There's 2 of them, so that's a 2 positive. So 2 plus 8 negative is negative 6. The whole thing adds up to 0, so this must be a 6 positive. So the sulfur is a 6 positive. 2 negative, but there's 2 of them, so that's 4 negative. The whole thing's got to add up to 0, so this nitrogen must be a 4 positive. 2 negative, 1 positive. That's your first step. Again, please pause the video and keep trying these parts on your own, following those instructions. It's the only way to make this information stick. The next step is to circle the ones that have oxidation numbers that change. So my sulfur changes, goes from a 2 negative to a 6 positive. My nitrogen goes from a 5 positive to a 4 positive. The next step, identify the oxidation number for an element that gets smaller or is reduced. The nitrogen goes from a 5 positive to a 4 positive. I write reduced. Reduction is the gain of electrons. So reduction, gain, and it gained 1 electron to go from a 5 positive to a 4 positive. Then I do the other one that I circled. That must be my oxidation. Oxidation is the loss of electrons. If you lose negative charges, then you become more positive. I'm going from 2 negative to 6 positive. That's losing or lost 8 electrons. It's a lot of electrons to lose. That's my steps. My next step is to fill in the 4 boxes at the top, and if you did a good job with your brackets, this should be fairly easy. So what is oxidized? My sulfur. What is reduced? My nitrogen. Then we go to the agents, which is a little bit harder to understand. What caused this sulfur to lose electrons? Well, it was this nitrogen right here needing to gain electrons. So the nitrogen is the oxidizing agent, but the whole thing comes down. So the oxidizing agent is always going to be the whole chunk. In our last problem was a bunch of single things. So the whole chunk was a single thing. In this one, the whole chunk is a whole chunk. So this is what is reduced, this nitrogen, but it's in this molecule. So this molecule causes that sulfur to become oxidized. So the HNO3 is the oxidizing agent. Reducing agent. This nitrogen needs to gain electrons. So what forced it to gain electrons? It was the sulfur needing to lose electrons. So the H2S that contains the sulfur that needs to lose electrons is the reducing agent. Everything is found for those 4 boxes on the reactant side. Continuing to go down the cover, I write out the oxidation half reaction. I go from one end of the bracket to the other end of the bracket. So H2S is on one side of the bracket, H2SO4 is on the other side of the bracket. First step is to balance everything besides hydrogen and oxygen, and the sulfurs are balanced. The next step, balance the oxygens by adding water to the side that needs more O's. I have 4 O's here, so I add 4 H2O's over here. Again, you can pause the video at any time to try to do parts of this problem by yourself. The next step is to balance the hydrogens. I have 8 here, I have 2 here, so that's 10. Here I have 2, so I have to add 8 hydrogen ions over on this side. Now I need to balance the charges. On the reactant side, 0 for a charge. On the product side, there's these 8 positives, so I add 8 electrons to this side. Now I do the reduction half reaction. I go from bracket to bracket. HNO3 to NO2. Balance everything besides the hydrogens and the oxygens. The ends are balanced. We're good to go. Balance the oxygens by adding water to the side that needs more O's. So I add 1 H2O on this side. If you don't get that, pause it, really take a look at it. Now I balance the hydrogens by adding hydrogen ions. I have 2 H's here, I have 1 H here, so I add a hydrogen ion to this side. Now I have to balance the charges. No overall charge on this product side, but over here I have a 1 positive, so I add 1 electron. Couple little points. In the oxidation, electrons are always found over here. In a reduction, electrons are always found over here. If you don't have them on the correct side, that means you must have done something wrong with the problem. Next step, I need to make sure that my electrons are the same number throughout. So this needs to be 8 electrons, and this needs to be 8 electrons. So what's lost is equal to what's gained. So I'm going to multiply this bottom one by 8. Top one, I really don't have to multiply by anything. So it's not 1 electron anymore, it's 8. It's not 1 hydrogen, it's 8. It's 8 nitric acids, it's 8 nitrogen dioxides, and it's 8 waters. So that's done. Now I have to fill in this bottom part. So these electrons are found on both sides, and they cancel each other out. So those electrons are gone, and that's why in the very bottom part down here, there's no electrons there, there's no electrons there. In this one, I have 8 hydrogen ions here. I have 8 hydrogen ions here, so they are on different sides of the arrow. They cancel each other out, and that's why there's no hydrogen ions over here and no hydrogen ions over there. Waters, I have 4 H2Os here, I have 8 H2Os here. So these 4 get wiped out, and that's why there's no water on this side. And this 8 drops down to a 4. H2S, I have 1 of those. HNO3, I have 8 of those. H2SO4, I have 1 of those. And I have 8 of the NO2, and I am balanced. This is probably one of the more complicated things that we do all year, so please replay this if you need to. You have a few problems that you have to do, and there is 1 extra credit problem to do if you wish to do it. Have a good day.